Now let's discuss molecular formulas, or the actual formulas of a chemical compound. So empirical formulas, which we talked about previously, are actually of limited utility. If you really want to know what the compound's formula is, you need to figure out its molecular formula. And you can get the molecular formula from the empirical formula if you know the molecular mass, or the molar mass, or the molecular weight. Those are all synonymous terms. So the basic idea is that if you have the empirical formula and you multiply it through by some integer, I'm going to call it n, you can get the molecular formula. And that integer n is determined from the ratio of the number of the molecular mass to the empirical mass, or it really represents the number of empirical units that you have in that molecule, within that molecule. So if you know the molecular mass and you know the empirical mass, then that ratio is your n. As always, I want to do an example to show you what I mean by this rather abstract language. Okay, so molecular mass over empirical mass. Let's do a simple example where we have a compound that has the empirical formula of CH2O. We know that this compound has a molecular mass of 180 grams per mole. What is the molecular formula of this compound? So we can solve this problem by basically calculating the value for n, taking the molecular mass and putting it over the empirical mass. So what is the empirical mass? Well, you take the empirical formula and you can use the atomic masses within that empirical formula to calculate the empirical mass. So we have carbon and 2 hydrogens and 1 oxygen. So that's going to be 12.01 plus 1.01 times 2 plus 16. So if I sum up all of those, I get an empirical mass of about 30 grams per mole. I'm going to round it to a whole number because I have the molecular mass rounded to a whole number. So this is the empirical mass. Now to calculate my n value, I need to take the molecular mass and divide by the empirical mass. So 180 grams per mole divided by 30 grams per mole gives me a ratio of 6. So that means I can take that empirical formula, CH2O, and multiply through by 6, a factor of 6. So that's giving me 6 carbons. 6 times 2 is 12 hydrogens and 6 oxygens. This is the molecular formula. And you should recognize this, of course. It is the molecular formula of glucose, which is a sugar molecule, C6H12O6. So you see that figuring in photosynthesis. Let's do another example where we combine empirical and molecular formulas. Vanillin is what gives vanilla extract its flavor. And vanillin has a molecular weight, which is a synonym for molecular mass, of 152.08 grams per mole. It has the following percent composition, and this is a mass percent composition. So this is a percent composition by mass. 63.18% carbon, 5.26% hydrogen, and 31.56% oxygen. Can we use this information to find the empirical and the molecular formulas of vanillin? So the first part of this is what we've done before, the empirical formula. To find the empirical formula, you can use the strategy where you assume that you have 100 grams of the compound. And from there, your mass percentages can be converted into moles. Okay, this enables us to get the molar ratio. So if you have 100 grams of vanillin, that means that you're going to have 63.18 grams of carbon, 5.26 grams of hydrogen, and 31.56 grams of oxygen. Now you need to look up the atomic masses and multiply each of these by the reciprocal of the atomic masses. So we have carbon's atomic mass, this is from the periodic table, hydrogen's atomic mass, and oxygen's atomic mass. Doing this enables us to cancel the grams. Oops, I needed to write my unit here. Cancel the grams and be left with the moles. And the whole rationale here is that I want to figure out the molar ratio of these elements to each other. So this gives me 5.26 moles of carbon, 5.26 moles of hydrogen, and that is not a coincidence, and 1.97 moles of oxygen. So that means my C to H to O ratio is established. Now, what you want to do to simplify that ratio is take these three numbers and divide all of them by the smallest number. So divide all of them by 1.97. And that will give you a ratio of 2.67 to 2.67 to 1. Okay, what that does is it converts the smallest number into 1. But I have more work to do. I want a whole number ratio. So what you need to do is multiply them through by a common factor. Now you probably know that 0.67 is 2/3. So multiplying through by 3 here is going to be the way to convert all of these to whole numbers. If you don't see that, you can start by multiplying by 2, then you can multiply by 3, then you can multiply by 4. You can kind of work your way up. But if I multiply all of these by 3, I'm going to get something very close to a whole number ratio, 8 to 8 to 3. So that whole number ratio gives me an empirical formula of C8H8O3. That is the empirical formula of my mystery compound. Now, let's use this to calculate what we call the empirical mass. So I have 8 carbons, 8 hydrogens, and 3 oxygens. So looking up the atomic masses, I have 12.01, that's going to be multiplied by 8, 1.01 times 8, and 16 times 3. So all of that together, if I do that multiplication and I add them all up, that is going to give me an empirical mass of 152.08 grams per mole. Now let's go back to the problem. The problem told me that vanillin has a molecular weight of 152.08 grams per mole. So this is a situation where the empirical mass is equal to the molecular mass. So that means that my N factor, which is just the ratio of the molecular weight to the empirical weight, that's going to be 152 divided by 152. So that's going to be 1. So the empirical formula is the molecular formula. C8H8O3 is the molecular formula as well as the empirical formula. So this can happen. Sometimes your molecular formula is identical to the empirical formula.